Welcome to this pre-recorded lecture on mediation analysis. In this lecture, I will provide an introduction to mediation analysis. Before I dive into the content of this lecture, let me briefly introduce myself. My name is Judith Reinhardt, and I'm currently an assistant professor of epidemiology at the University of South Florida. I started my scientific career back in 2009 when I started my bachelor's degree in nursing at the Windesheim University of Applied Sciences. After I completed my bachelor degree in nursing, I ended up pursuing a master's in health sciences with a focus on prevention and public health at the VU University. After that, I decided I wanted to learn more about epidemiology and epidemiologic methods, so then I pursued a second master's degree in clinical epidemiology from the Erasmus University. I ended up going back to the VU University and very specifically to the VU University Medical Center to obtain my PhD in epidemiology in 2021. And then after that, I was a postdoctoral researcher at the Amsterdam University Medical Center for a while. Generally speaking, my research interests are kind of twofold. Some of my research is focused on the evaluation and application of methods for statistical mediation analysis. This is also what I wrote my PhD dissertation on. And then more recently, I started developing an interest in health disparities in late life cognition and dementia. And in this second line of research, I actually apply mediation analysis a lot. In this lecture, I'll start by laying out the basic principles of mediation analysis. Then we'll talk about mediation effects. So in other words, what are the effects that we're trying to estimate when we do a mediation analysis? I'll talk about two different types of mediation analysis methods. The first one is traditional mediation analysis methods, and the second one is causal mediation analysis methods. Then I'll go over some suggested readings. And then finally, I'll end this lecture with some take-home messages. So let's start with the basic principles. Often in scientific research, we're interested in estimating the effect of an exposure on an outcome. For example, we might be interested in determining whether childhood adversity affects substance abuse. However, what often remains unknown is how an exposure affects an outcome. And this is where a mediator comes in. A mediator is a variable that is affected by the exposure and in turn affects the outcome. And therefore the mediator is on the causal pathway of the exposure to the outcome. And it thus explains how the exposure affects the outcome, or in other words, how the exposure transmits its effect on the outcome. If we go back to the example of childhood adversity and substance abuse, then anxiety might be a mediator. So the hypothesis here might be that individuals who experience childhood adversity on average have higher levels of anxiety, and that individuals who have higher levels of anxiety on average have a higher risk of developing substance abuse. So in this case, anxiety explains how childhood adversity transmits its effect on substance abuse. And when we build our mediation hypotheses, there are a few things that we need to keep in mind. And when I build my own mediation hypotheses in my own substantive work, there are always two questions that I ask myself. The first question is, does a change in the exposure cause a change in the mediator? And the second question is, does a change in the mediator cause a change in the outcome? The reason that we need to ask these two questions is because if the answers to both of these questions is yes, then the mediator that we have in mind is indeed on that causal pathway of the exposure to the outcome. And we typically use subject matter knowledge to build our mediation hypotheses. And when we talk about subject matter knowledge, we might get that from some previous studies that have been done that have showed, for example, that indeed changes in the exposure lead to changes in the mediator. Perhaps there have been some other studies that have showed that changes in the mediator cause changes in the outcome. So we can piece together these previous pieces of information to put together our mediation hypotheses. In some situations, there are also theories that we can use. So an example of a theory that we might use to put our mediation hypotheses together is the health behavior model. So we can use those previous studies and those theories to develop our mediation hypotheses. So in our example of childhood adversity and substance abuse, we would ask ourselves, would a change in childhood adversity lead to a change in anxiety? And we would also ask ourselves, would a change in anxiety lead to a change in substance abuse? Now here we have another example of a mediation hypothesis. So in this case, discrimination is our exposure of interest and depressive symptoms are our outcome of interest. The idea here is that individuals who experience a lot of discrimination have more depressive symptoms. In this example, internalized stigma is the mediator. And the idea here is that individuals who experience more discrimination also experience more internalized stigma, and that individuals who have more internalized stigma have more depressive symptoms. So in other words, if we were to make a change in discrimination, we would expect that to lead to a change in internalized stigma. And if we were to make a change to internalized stigma, we would expect that to result in a change in depressive symptoms. Then this is another example of a mediation hypothesis. In this example, we have perhaps an experimental study because individuals undergo a mindfulness intervention. The outcome here is anxiety, so perhaps this mindfulness intervention was designed to reduce anxiety. The hypothesized mediator here is sleep quality. So the idea here is that individuals who undergo the mindfulness intervention on average have better sleep quality, and that individuals who have better sleep quality have less anxiety. So that's how sleep quality may explain how the mindfulness intervention affects anxiety. In this lecture, we focus on mediators. And mediators are what we call a type of third variable. There are also two other types of third variables, and they are called confounders and colliders. And it's important to note that mediators, confounders, and colliders are all statistically the same. So if we were to look at the relation between an exposure and a mediator, or an exposure and a confounder, or an exposure and a collider, just on a purely statistical level, then we would notice that each one of those third variables is associated with the exposure. And the same holds for the outcome. So a mediator, confounder, and a collider will all appear to be associated with the outcome. So purely based on statistical methods, we cannot distinguish between mediators, confounders, and colliders. It is therefore really important that we use subject matter knowledge to distinguish between mediators, confounders, and colliders. So a mediator is a variable that is influenced by the exposure and in turn influences the outcome. And therefore it is on the causal pathway from the exposure to the outcome. A confounder differs from a mediator in that a confounder is not influenced by the exposure. Instead, a confounder influences the exposure. A confounder also influences the outcome, but because it is not influenced by the exposure, it is not on the causal pathway from the exposure to the outcome. So in other words, it does not explain the mechanism through which the exposure affects the outcome. When we go back to our example of childhood adversity and substance abuse, then childhood socioeconomic status might be a confounder. Children with a lower childhood socioeconomic status might be at higher risk of childhood adversity. And childhood socioeconomic status may also increase the risk of substance abuse. So in other words, childhood socioeconomic status affects both childhood adversity and substance abuse. And it's important to note here that I made the arrow of childhood socioeconomic status to childhood adversity green. And this green arrow is different from the arrow that we would expect if we had a mediator, because now the arrow points from childhood socioeconomic status to the exposure, which is childhood adversity here. So in this case, childhood socioeconomic status is a confounder of the association between childhood adversity and substance abuse. And if we want to make sure that we estimate an unbiased effect between childhood adversity and substance abuse, we want to adjust or effect estimate for childhood socioeconomic status. Then another type of third variable is a collider. And while a lot of people have heard about a confounder, colliders have received less attention in the literature. It's still important to know, though, how a collider differs from a mediator, because when we build our mediation hypotheses, we want to make sure that our hypothesized mediator is not a collider. We really want to make sure that our hypothesized mediator meets the mediator criteria. So a collider, like a mediator, is influenced by the exposure, but the important difference between a mediator and a collider is that a mediator influences the outcome, but a collider is influenced by the outcome. And because the collider is influenced by both the exposure and the outcome, it is not on the causal pathway from the exposure to the outcome. Instead, we can think about the collider as a common consequence of both the exposure and the outcome. So it's something that happens after the exposure and the outcome. If we go back to our example of childhood adversity and substance abuse, then maybe suicidal ideation would be a collider. The idea here is that individuals who experience childhood adversity may be at higher risk of suicidal ideation, and that individuals who are abusing substances are also at higher risk of suicidal ideation. It's important to note here that I've made the arrow from substance abuse to suicidal ideation green, because this is the arrow that points in the opposite direction from what we would expect if we had a mediator. So in this case, suicidal ideation is a common consequence of both childhood adversity and substance abuse, and is therefore not on that causal pathway of the exposure, childhood adversity, to the outcome, substance abuse. When I build mediation hypotheses, I always like to map out the timing of the factors that I'm interested in. Because once I understand the timing of each of those factors, it becomes easier to determine whether the third variable that I'm looking at is a confounder, a mediator, or a collider. So when we think about our exposure and our outcome, we would expect to observe a change in our exposure prior to a change in our outcome. Now, if the third variable that we're looking at is a confounder, then we expect that the change in the confounder happens first, and that would lead to a change in the exposure and to a change in the outcome. So timing-wise, the confounder happens before the exposure and the outcome. When we think about a mediator, then the timing of that mediator would be in between the exposure and the outcome, such that a change in the exposure will happen first and will lead to a change in the mediator. And a change in the mediator will then subsequently lead to a change in the outcome. Finally, when the factor that we're interested in is a collider, then we expect that first a change in the exposure would happen, a change in the outcome would happen, and that then these changes in the exposure and the outcome would lead to changes in the collider. It is important to note that when I'm talking about the timing of each of these phenomena, I am talking about the timing of these phenomena kind of in real life. So I'm not talking about the time at which we measure these variables. So we're really just thinking about the theoretical level here of when these factors change and how that would affect the other phenomena that we're interested in. So just to summarize, a mediator is a variable that is affected by the exposure and in turn affects the outcome. Therefore, a mediator is on the causal pathway from the exposure to the outcome. And it represents that mechanism through which the exposure transmits its effect on the outcome. It is important to note that we need subject matter knowledge to build our mediation hypotheses, because we really want to make sure that when we study a mediator that it's truly a factor that is affected by the exposure and that in turn affects the outcome. Because if we're not careful, we might mistake confounders and colliders for mediators. So we always want to use that subject matter knowledge to underpin our mediation hypotheses. Now that we know what a mediator is, let's talk about the mediation effects that we aim to estimate when we do a mediation analysis. So the goal of a mediation analysis is to determine what part of the total exposure outcome effect is explained by the mediator and what part of the total exposure outcome effect is not explained by the mediator. So the goal of a mediation analysis is to decompose the total exposure outcome effect into an indirect effect, which is the part that is explained by the mediator, and a direct effect, which is the part that is not explained by the mediator. So the indirect effect is the effect of the exposure on the outcome through the mediator. And when we go back to the diagrams that I've showed you before, we can think of the indirect effect as the combination of the arrow from the exposure to the mediator and then the arrow from the mediator to the outcome. So it's the pathway of the exposure to the outcome that goes through the mediator. If we go back to our example of childhood adversity and substance abuse, then the indirect effect is the effect of childhood adversity on substance abuse that goes through anxiety. So the indirect effect would consist of the arrow from childhood adversity to anxiety and the arrow from anxiety to substance abuse. The direct effect is the effect of the exposure on the outcome, not through the mediator. So in terms of the diagram that we've been going over in this lecture, the direct effect is represented by the directed arrow from the exposure to the outcome. So if we go back to the example of childhood adversity and substance abuse, then the direct effect is the effect of childhood adversity on substance abuse, not through anxiety. So the direct effect is really just represented by this one directed arrow from childhood adversity to substance abuse. Now, as a little side note, it is important to note that this direct effect of childhood adversity on substance abuse may contain indirect effects through other mediators than anxiety. So if other mediators exist, for example, depression, then this direct effect will contain those indirect effects. It's just not containing that indirect effect through our vocal mediator, which in this case is anxiety. Now the total effect is the effect of the exposure on the outcome, both through and not through the mediator. So the total effect is represented by both that indirect pathway of the exposure to the outcome through the mediator and the direct pathway of the exposure to the outcome. We can also think of the total effect as the sum of the indirect effect and the direct effect. If we go back to our example of childhood adversity and substance abuse, then the total effect is the effect of childhood adversity on substance abuse, both through and not through anxiety. So in other words, it captures both the indirect effect through anxiety and the direct effect not through anxiety. Just to summarize, the goal of a mediation analysis is to decompose the total exposure outcome effect into an indirect effect through the mediator and a direct effect not through the mediator. Now that we know what effects we're interested in estimating when we do a mediation analysis, let's talk about methods to actually estimate these mediation effects. And we can kind of distinguish two broad types of methods that we can use to estimate these mediation effects. The first one are traditional mediation analysis methods, and the second one are causal mediation analysis methods. And I'll start by going over the traditional mediation analysis methods. Traditional mediation analysis methods became popular after two seminal papers were published by Judd and Kenny in 1981 and Barron and Kenny in 1986. And this paper by Barron and Kenny is actually one of the most widely cited papers ever. And these two seminal papers really spurred the uptake of traditional mediation analysis methods in psychological research. In traditional mediation analysis, the mediation effects are defined and estimated using linear regression coefficients. And when we perform traditional mediation analysis, we need to estimate 3 linear regression models. Before I go over the 3 linear regression models, let's go over some notation that's often used in traditional mediation analysis. So the total effect of the exposure on the outcome is often denoted by C. The effect of the exposure on the mediator is typically denoted by A. The effect of the mediator on the outcome is typically denoted by B. And then finally, the direct effect of the exposure on the outcome is often denoted by C prime. The first linear regression equation is used to estimate that C path, so the total effect of the exposure on the outcome. And to estimate this pathway, we use the outcome variable as the dependent variable, so here y represents the outcome variable. I1 represents the intercept, x represents the exposure, with the coefficient for x being the C coefficient, so that estimate of that C pathway, and then we have the error term. The second equation is used to estimate the effect of the exposure on the mediator. And in this equation, the mediator is the dependent variable. So here I have denoted the mediator with M. I2 is the intercept in this regression model. X is again the exposure. And the coefficient for X here is A. So it's the estimate of that pathway of the exposure to the mediator. And then we have an error term. Finally, the third regression model is used to estimate both that C prime pathway, so that direct pathway of the exposure to the outcome, and the B pathway, so from the mediator to the outcome. In this regression model, the outcome is again the dependent variable, which I've denoted here with Y. I3 represents the intercept. X represents the exposure, with C prime being the estimate of that C pathway. M is the mediator, with B being the estimate of the pathway from the mediator to the outcome, and then we have the error term. It's important to note that when we estimate the pathway of the mediator to the outcome, we always include the exposure in that regression model. And when we take a closer look at the diagram, we'll see that there is an arrow pointing from the exposure to the mediator and from the exposure to the outcome. And when we think back about the different types of third variables, this means that the exposure actually qualifies as a confounder of that mediator outcome association. So if we want to make sure that we estimate that B pathway without confounding bias by the exposure, we need to always include the exposure in that model as well. Now, as I mentioned at the beginning of this section of the presentation, in traditional mediation analysis, the effects are both defined and estimated using coefficients from 3 linear regression equations. So the total effect is defined and estimated as that C coefficient from the first regression equation. The direct effect is defined and estimated as the C prime coefficient from the third regression equation. And then the indirect effect can be estimated in two ways. So we can estimate it as the product of the A coefficient from the second equation and the B coefficient from the third equation. This is what we call the product of coefficients method. And we can also estimate the indirect effect as the difference between the total effect, so C, and the direct effect, C prime, which is what we call the difference in coefficients method. And these two methods for estimating the indirect effect will give you exactly the same effect estimate when all three regression equations are linear regression equations. So if we use linear regression models to estimate those three equations, then the product of coefficients method and difference in coefficients method will provide the same estimate of the indirect effect. Now, it's important to note that this does not necessarily hold when our mediator or outcome is a different type of variable than continuous. So if we, for example, have a binary mediator or a binary outcome, the product of coefficients method and difference in coefficients method will no longer give the same indirect effect estimate. And it's situation dependent which one of these two methods for estimating the indirect effect provides the correct indirect effect. And there are also models for which neither will provide the correct indirect effect. Just to summarize, traditional mediation analysis methods were originally developed based on linear regression models. In traditional mediation analysis, mediation effects are defined and estimated based on linear regression coefficients. There are two ways in which we can estimate the indirect effect. The first one is the product of coefficients method, so A times B. And the second way is the difference in coefficients method, C minus C prime. And when we estimate those regression equations using linear models, these two methods will provide the same effect estimate. However, if we estimate some of those models using other types of regression models, such as logistic regression analysis, A times B and C minus C prime will no longer give us the same indirect effect estimates. And it will be situation dependent which one will be preferred, and there are even situations in which neither is preferred. Let's now move on and talk about causal mediation analysis methods. So causal mediation analysis methods are based on the potential outcomes framework and the counterfactual framework. And some seminal papers on estimation methods for causal mediation analysis were published around 2010. And the first software packages for causal mediation analysis started appearing as of 2013. So it has really only been a little over 10 years that software packages have been available that allow researchers to perform causal mediation analysis. So this is a relatively new type of mediation analysis compared to these older traditional mediation analysis methods. So in causal mediation analysis, general effect definitions are provided based on counterfactuals. And an important difference with traditional mediation analysis is that in causal mediation analysis, the effect definitions are not tied to a specific type of regression model. They're very general, almost philosophical effect definitions of direct and indirect effects. And because the definitions of the mediation effects are not tied to a specific estimation method, there are actually multiple types of estimation methods that can be used to estimate direct and indirect effects in practice. So there are, for example, regression-based methods, simulation-based methods, imputation-based methods, weighting-based methods. So there are all these different types of methods that we can use to estimate our direct and indirect effects. Before we dive into causal mediation analysis methods, let's talk about causal effects. And very specifically, I want to ask you the question, when do we know for sure that an exposure causes an outcome? And the way that we can think about this question is, let's say that we have an individual who experienced childhood adversity. And let's say that this individual abuses substances. When would we know for sure that it was the childhood adversity that caused the substance abuse? So I'm going to give you a few seconds to think about this question. Okay, so let's go back to this individual who experienced childhood adversity and is abusing substances. The only situation in which we would know for sure that it was the childhood adversity that caused the substance abuse is if we were able to, let's say, access some sort of parallel universe in which this same individual would not be exposed to childhood adversity. All the other factors in that person's life are the same. The only difference is that in one of these two parallel universes, they experience childhood adversity and in the other they don't. And then we follow this individual over time in both of those parallel universes to see whether they end up abusing substances or not. So if they only abuse substances in the universe in which they experienced childhood adversity, but not in the universe where they didn't experience childhood adversity, then we would be able to claim that it was the childhood adversity that caused the substance abuse. And this is what counterfactuals are. Counterfactuals are essentially the parallel universes where in one universe we envision the individual to be exposed, and in the other universe we envision the individual to not be exposed, and then over time we observe to see what the outcome would be. And there is some specific counterfactual notation that we use in the literature. So y lowercase x would be the outcome value if individual A was exposed during time period t. So y here stands for the outcome, and lowercase x stands for the exposure value where the person is exposed. Yx star is the outcome value if individual A was not exposed during time period t. So x star here stands for a situation where the individual is not exposed. So little x and little x star denote the exposure values that we are comparing. So in the example that we've been using throughout this lecture, yx could be the outcome had somebody experienced adversity, and yx star would be the outcome had an individual not experienced childhood adversity. And the causal effect is then the difference between the two counterfactuals. So we would claim that there's no effect of the exposure on the outcome when the outcome value is the same across the two counterfactuals. We would say that there is an effect of the exposure on the outcome when the outcome value differs across the two counterfactuals. So let's go back to the example of childhood adversity and substance abuse. So let's say that yx is the substance abuse status at age 25 if individual A experienced childhood adversity. And then let's say that yx star is substance abuse status at age 25 if individual A did not experience childhood adversity. So again, little x refers to the situation where the individual experienced childhood adversity, and little x star refers to the situation where the individual did not experience childhood adversity. So to determine if there is a causal effect of childhood adversity on substance abuse, we would have to look at the difference in substance abuse status for individual A when having experienced childhood adversity versus not having experienced childhood adversity. So in other words, we would claim that there is an effect of childhood adversity on substance abuse. In other words, childhood adversity caused the substance abuse. If the individual was only abusing substances when experiencing childhood adversity, and not when the individual did not experience childhood adversity. We would conclude that there is no impact of childhood adversity on substance abuse if the outcome status is the same across the two counterfactuals. So if either across both yx and yx star the individual was abusing substances, or if across both of those counterfactuals the individual was not abusing substances. So by now you might be thinking this is all an interesting theoretical exercise, but in practice we're never going to be able to know both of those counterfactuals for one individual. And you're completely right. This is what we call the fundamental problem of causal inference. And the fundamental problem of causal inference states that it is impossible to observe both counterfactuals for the same individual over the same time period. In practice, we address this fundamental problem of causal inference by looking at these counterfactuals at the average level. So we might not be able to observe the counterfactuals at the individual level, but we might be able to observe it at the average level. And to denote the average level counterfactuals, we slightly extend our notation of the counterfactuals. So what we do is we include an E and then brackets around yx, and the same an E and then a bracket around yx star to denote that we're now looking at the average potential outcomes. So the E really just denotes that we're looking at an expected value of the outcome in individuals who are exposed or in individuals who are not exposed. This expected value can be represented by the average. So yx would then be the average outcome value in a group of individuals exposed during time period t, and yx star would be the average outcome value in a group of individuals not exposed during time period t. And then once we have these average level counterfactuals, we can estimate the average causal effect. And we can estimate this as the difference between the two average level counterfactuals. When we estimate a causal effect using average level counterfactuals, it is important to note that we do need to make a causal assumption. And the causal assumption is that the two groups that we are comparing are the same in all aspects other than the exposure. Remember, when I was talking about the two parallel universes, where in one universe the individual was exposed and in the other the individual was not exposed, I did say that we were assuming that all the other factors in that individual's life were the same across the two parallel universes. And that's essentially what this causal assumption is trying to get at. We do need to make sure that all the other factors that are relevant are the same across the two groups that we are comparing. And in perhaps more familiar terms, this means that we are assuming that there are no unmeasured confounders of the exposure outcome effect. Now, I've put unmeasured in parentheses here because if we've measured confounders, we can adjust for them in our statistical analyses. But if we have not measured relevant confounders, then our effect estimate will be biased. Now let's go back to our example of childhood adversity and substance abuse. In our example of childhood adversity and substance abuse, our average counterfactual yx would be the percentage of people who abuse substances at the age of 25 among all people who experience childhood adversity. And our average counterfactual yx star is the percentage of people who abuse substances at the age of 25 among all people who did not experience childhood adversity. Now, the average causal effect is the difference between these two average level counterfactuals. So in this case, it would be the difference in the percentage of people who abuse substances at the age of 25 between people who did experience childhood adversity and those who did not experience childhood adversity. So in other words, we can think about the average causal effect as a risk difference. Now, when it comes to counterfactuals in a mediation analysis, it is important to note that the counterfactuals will depend on both exposure and mediator values. And more specifically, we'll have mediator counterfactuals nested within outcome counterfactuals. The two mediator counterfactuals that we might observe are mx and mx star, where mx is the mediator value for individual A when exposed during time period t, and mx star is the mediator value for individual A when not exposed during time period t. So note here that these mediator counterfactuals are essentially interpreted the same way as the outcome counterfactuals, but now instead of having the outcome y, we have the mediator m in OR notation. Now that we've defined our mediator counterfactuals, we can include these mediator counterfactuals or nest these mediator counterfactuals within our outcome counterfactuals. And when we do this, we can define 4 different outcome counterfactuals. So the first nested outcome counterfactual that we can define is yxmx. And we can interpret this counterfactual as the average outcome in a group of individuals who are exposed during time period t. The second counterfactual is yx star mx star, and this is the average outcome in a group of individuals not exposed during time period t. Then there is yx mx star, so this is the average outcome in a group of individuals who were exposed during time period t when we set everyone's mediator value to the value that would have been observed had they not been exposed. And then finally, there is yx star mx, and this is the average outcome in a group of individuals who were not exposed during time period t, so that's what x star refers to, while we set the mediator for everyone to the value that would have been observed had they been exposed. So in other words, we set the mediator to mx. Now it's important to note that these first two nested counterfactuals can be directly computed based on the data, because these are essentially the average outcome values for either the exposed, so that's that first nested counterfactual, or the average outcome value for the people who were not exposed, so that's the second nested counterfactual. The other two nested counterfactuals cannot be observed from the data, but we can use statistical methods to estimate these last two counterfactuals. And there are various estimation methods available to estimate these counterfactuals. So, like I already said before, we have regression-based methods, simulation-based methods, imputation-based methods, weighting-based methods. There are really all these different types of methods that we can use to get these 4 nested counterfactuals estimated. And then the causal mediation effects are again estimated as the difference between the estimated counterfactuals. And when the indirect and direct effects are defined based on differences between nested counterfactuals, we typically call them natural indirect effects and natural direct effects. So the natural indirect effect is defined as the difference between two nested counterfactuals in which the exposure is held fixed, but the value of the mediator differs between the two nested counterfactuals. So when we look at the two counterfactuals that I've put on this slide here, we see that the value of the exposure is held the same across the two nested counterfactuals. So for both of them, it's set to little x, whereas the value of the mediator differs. So in the first counterfactual, the mediator is set to the value observed if an individual would be exposed. And in the second counterfactual, the mediator is set to the value that would have been observed had an individual not been exposed. So by fixing the value of the exposure, we kind of disable that direct effect of the exposure to the outcome. And by differing that mediator value, we allow only the part of the exposure to the outcome to be transmitted through the mediator. So it gives us an insight into that indirect effect. Then for the natural direct effect, it's the other way around. So for the natural direct effect, we compare two nested counterfactuals for which we differ the value of the exposure, but we keep the value of the mediator fixed across the two nested counterfactuals. So here we see two nested counterfactuals where we set the exposure in the first counterfactual to x and in the second counterfactual to x star. We also see that the value of the mediator in both nested counterfactuals is set to the value that would have been observed had the individuals not been exposed. So we're kind of disabling here that pathway that goes through the mediator, and we're only allowing the exposure to transmit its effect on the outcome directly. Then for the total effect, we take the difference between two counterfactuals for which both the exposure and the mediator value differ. So in the first counterfactual here, we set the exposure to the value x, and we set the mediator to the value that would have been observed had the individuals been exposed. And in the second counterfactual, we set the exposure to x star, so the not exposed value, and we set the mediator to the value that would have been observed had the individual not been exposed. So this allows the effect of the exposure to the outcome to be transmitted both through the mediator and not through the mediator. So we get the complete effect, the total effect of that exposure on the outcome. Now, like I said, there are many different methods that we can use to estimate these causal mediation effects. And the idea behind each of these methods is that it estimates those average level potential outcomes and then takes the difference between those average level potential outcomes. So in the regression-based method, the potential outcomes are estimated based on regression coefficients. And there are actually a lot of different packages that implement a regression-based method for causal mediation analysis. So for example, there's RegMedInt in R, there's Paramed in Stata. Linda Valerie and Tyler Vanderweel have developed macros that are available for SPSS and SAS. There's also ProcCausalMed in SAS. So pretty much any software program that's often used by researchers in the social sciences have a package available that can be used to estimate causal mediation effects using this regression-based estimation method. There's also the simulation-based method, which simulates the potential outcomes using regression models as input. And that method is available in the mediation package in R. There's also the imputation-based method. And the imputation-based method essentially treats the unobserved potential outcomes as missing values, and then imputes these missing potential outcomes in order to estimate the causal effects. And this imputation-based method is implemented in Medflex in R. Then finally, there's also the weighting-based method. And the weighting-based method standardizes the outcome to the distribution of the mediator through weighting. And this weighting-based method is also available in Medflex in R. Just to summarize, causal mediation analysis provides general effect definitions based on counterfactuals. The strength of this is that causal mediation analysis is not tied to linear regression models, and therefore it can be used to estimate mediation effects for any type of mediation model. So it can also be used for mediation models where, for example, the mediator is binary or the outcome is binary. The only drawback still of causal mediation analysis methods is that there's limited availability of software for complicated mediation models. So if we have mediation models with, for example, longitudinal data or complex types of mediators or outcomes, like count outcomes or survival outcomes, then there are limited software options to actually estimate these kinds of models. In this lecture, I gave a brief introduction to mediation analysis. However, there's much more to learn about mediation analysis if you're interested in actually applying this in your research project. Therefore, I've compiled a list of suggested readings that can kind of help you further if you have a project in which you want to apply mediation analysis. So the first 3 references on this slide are good introductory texts. So Andrew Hayes and David McKinnon both wrote seminal books on mediation analysis. These books cover a wide range of topics. Andrew Hayes' book contains a lot of information on moderated mediation and multiple mediator models. And David McKinnon's book is a bit more comprehensive in that it also covers a wide variety of types of mediation models. For example, models with latent variables, longitudinal models, models with categorical variables. So both of these books are great resources if you're interested in doing a mediation analysis. Then a few years ago, together with colleagues, I published a paper in which we described what kind of methods are being used in practice, and then we provided some recommendations for people who want to apply mediation analysis in practice. In this paper, we provided an introduction to both traditional mediation analysis and causal mediation analysis. So this might also be a good starting point if you're interested in applying causal mediation analysis. I also included 3 references to seminal papers on causal mediation analysis. The first one is by Imai and colleagues, the second one is written by Judea Pearl, and the third one is written by Tyler van der Wiel and Stijn van Steeland. Then there are 2 papers that are specifically focused on software for mediation analysis. The first one is a paper that I co-authored with some of my colleagues in which we described causal mediation software programs in R, M+, SAS, SPSS, and Stata. This paper provides a nice overview of all the different options that you have in each of these software programs. Then after we had published that paper, there was a package that was developed, it's called CMA First, that has a lot of different functions in it. So I just wanted to point out this package specifically as well, because if there are certain things that you can't find in the programs that we described in our earlier paper, then it would be worth looking at the CMA First website to see if their package would potentially facilitate that kind of mediation model. And then finally, it's important to note that there is also a reporting guideline for when you do a mediation analysis. It's called the AGRIMA statement. So if you are planning on doing a mediation analysis and you want to publish it in a journal, then please make sure to review this AGRIMA statement and make sure to report your mediation analysis in accordance with this AGRIMA statement. To end this lecture, I have a few take-home messages. The first take-home message is that mediators are variables that are affected by the exposure and that affect the outcome. So mediators are variables that are on that causal pathway from the exposure to the outcome and explain how the exposure affects the outcome. The second take-home message is that the goal of a mediation analysis is to decompose the total exposure outcome effect into an indirect effect through the mediator and a direct effect not through the mediator. And then finally, the third take-home message is that causal mediation analysis is preferred for most mediation models because it is based on general effect definitions, and there are many different estimation methods that we can use to perform causal mediation analysis. This brings me to the end of this pre-recorded lecture. I hope that you found this lecture informative and that you have a better sense now of what a mediation analysis is and what the steps are that we go through when we do a mediation analysis. If you have any questions regarding this presentation, feel free to send me an email. My email address is jreinhardt@usf.edu.